Everybody, I wanted to go over these basic counting principles today. So the basic counting principles, there's two of them, the addition principle and the multiplication principle. So what I'm going to do is go through and solve some applications using both that addition principle and the multiplication principle. And I'm going to show you some examples of Venn diagrams and tree diagrams. Okay, so it's just a bunch of examples. Let's plow through them. So a college offers 2 general education courses in history, 3 in science, 2 in math, 2 in philosophy, and 1 in English. If a freshman decides to take one course in a semester, just one of these, how many are possible? Here's an example of where we're going to use the addition principle. So there are 2 courses in history, 3 in science, 2 in math, 2 in philosophy, and 1 in English. So we're going to add all those together. 2 plus 3 is 5, plus 2 is 7, plus 2 is 9, plus 1 is 10. So that means there are 10 possible choices. Now, if the freshman takes one of each of these, how many are possible? Here's an example of the multiplication principle. So what we're going to do is instead of adding those, so remember here we added 3 plus 2 plus 2 plus 2 plus 1. Here we're going to multiply 3 times 2 times 2 times 2 times 1. And so 6 times 4 is 24. So the answer is 24. Okay, next example. A shopping center includes Wendy's, Burger King, and Popeyes restaurants, and a Nike and Champion outlet. If a couple decides to go to dinner and then shopping, how many choices are possible? So if they're going to go to dinner to one of those restaurants and then shopping to just one of those restaurants, this is an example of the multiplication principle. So there are 3 choices for dinner and 2 for shopping. 3 times 2 is 6. It's also a nice example, because it's smaller, where you could use a Venn diagram, or no, I'm sorry, not a Venn diagram, a tree diagram to represent this information. So for example, you have Wendy's or Burger King or Popeyes as your restaurants. And if you decide to go to Wendy's, then from Wendy's you could decide to go to Nike or the Champion outlet. If you went to Burger King, you could decide to go to Nike or the Champion outlet. And same thing if you went to Popeyes. Here you can see you look at this last branch, so to speak, of the tree, and there are 1, 2, 3, 4, 5, 6 ends to those branches. So there are 6 possibilities. The same thing we got with the multiplication principle. Okay, next example. The 14 colleges of interest to a student include 6 that are expensive, 7 that are far from home, and 2 that are both. They're both expensive and far from home. Here's a perfect example of where we're going to use a Venn diagram. Inside that Venn diagram, we're going to make sure that the numbers add up to 14. So I'm just going to write that here. Remember, whatever numbers we put inside here have to add up to 14. The 2 circles we have are the circle that represents the expensive colleges and the circle that represents the colleges that are far from home. Notice that there are 2 that are both. That's going to be in this overlap. So there are 2 that are both expensive and far from home. Now I'll work backwards. There are 7 that are far from home. So since we already have 2, there's 5 left unaccounted for. So that's what's going to go in that part of the circle that is just far from home. So you could say 5 of the schools are far from home, but not expensive. And then remember, working backwards, there are 6 that are expensive. We already have 2 of those, so that means there are 4 left. Now, here we come to that 14. We got to make sure that these numbers add up to 14. So 4 plus 2 is 6, plus 5 is 11. So there are 3 leftover schools. You could say these are the 3 schools that are not expensive and not far from home. Okay, now let's look at some examples. So the 14 colleges of interest, and we talked about that. That's what made our Venn diagram. So now let's go to the question. If the student selects a school not expensive and close to home, that means it's not far from home, how many choices are possible? So not expensive means outside of, sorry, I got in a weird choice there. But not expensive means outside of this circle. Okay, I'm going to redo that. Okay, so outside of this circle. And close to home means outside of this circle. So anything not in those circles. So that number is 3. And that's the answer to this question. Okay, next one. So same problem with the 14 schools, same Venn diagram. But now let's look at this question. This one says, if a student decides to attend a school that is not expensive and close to home, then transfer to a school that is not expensive but far from home, how many selections of the 2 schools are possible? So there are 2 things happening. First, we're going to find that first school, and then the student is going to transfer. So that's the second school. So we're going to use this Venn diagram and the multiplication principle. So how many choices of the first school are there? Well, it's not expensive and close to home. Remember, that was that 3. Now for the second school, it's not expensive but far from home. That's going to be that number 5. So this answer is going to be 15. I ran out of room. I'll put it over here in that corner. Okay, so that answer is 15. Okay, I'm going to switch gears here and look at 2 more examples. I hope you have your calculator handy because you're going to need it for these. These are going to be a little bit longer. So what I want you to look at is, it says a password consists of 2 letters followed by 3 digits. There are 26 letters in the alphabet and there are 10 digits, the numbers 0 through 9. Okay, so how many passwords are possible if no letter and no digit is repeated? So remember, it's going to be 2 letters followed by 3 digits. So the 2 letters, and nothing is allowed to be repeated, that means we have 26 choices for the first letter and 25 choices for the second letter. Remember, it can't be repeated. Then we have 10 choices for the first digit, 9 for the second, and 8 for the third. So we're going to multiply those all together. So 26 times 25 times 10 times 9 times 8 is 468,000. That's how many choices there are. Okay, how many are possible? This is the next question. How many are possible if letters can be repeated but successive digits are different? Well, if the letters can be repeated, that's 26 times 26. Now, what about those numbers? So we can pick any number for the first digit, but the next digit can't be the same as that. So I only have 9 choices left. So remember, these 2, I'll highlight this. This number and this number are not going to be the same, right? They're going to be different. So I can't use this digit again. So that means I still have 9 choices for that last digit. So this one is going to be 26 times 26 times 10 times 9 times 9. And that total is 547,560. Okay, I hope that helped. I jam-packed this with a lot of examples. Feel free to watch it again and pause if you need to. Good luck. Email me with your questions.